Before you move forward in this lesson, it's important that you feel comfortable already with SQL. You should feel comfortable with all of the commands that are listed on this slide. For manipulating data, you should feel comfortable with insert, update, and delete commands. For querying data, you should feel comfortable with the select statement and various ways that you can use a select statement to grab certain records from a database. You should feel comfortable with the commands create table, alter table, and drop table, as well as operations for adding and dropping columns on a table. And finally, you should feel comfortable with joins, know what inner joins are and outer left or right joins are, and also know how to group data with group bys, counts, and sums. Okay, so let's get started with learning how to use SQL Alchemy. What is SQL Alchemy? SQL Alchemy is a particular Python library that's extremely popular for interacting with databases and developing database-backed web applications with. On the SQL Alchemy docs, it describes itself as a Python SQL toolkit. In other words, it provides end-to-end tools where you can work with relational databases without writing SQL directly like we were doing with PG2. One thing about SQL Alchemy is that it offers a type of library called an ORM, which is really popular for interacting with databases from a web app. An ORM is otherwise known as an object-relational mapping library. The important thing about an ORM is it allows us to map database tables and columns to class objects and attributes instead, so that when you use an ORM and you interact with the database with it, you no longer work in tables and columns, and you only work using your knowledge of object-oriented programming in order to work directly with classes and attributes. Here's how it would look like if you were to use SQL Alchemy ORM instead. So instead of writing a create table SQL statement in a Python script, we would instead use Python classes. To write this exact same create table statement for creating a to-dos table, we can instead instantiate a to-do class. It inherits from some sort of model class here, which comes from SQL Alchemy ORM, which does a lot of things under the hood for actually creating the table for you. And from here, you could just write attributes of the class to-do, which would include ID, description, and column, mapping to certain properties that would allow us to create database columns for ID, description, and completed. As a result of creating this class to-do, we can do certain things with it which would mirror operations that we would do in a relational database. So for example, to do a typical select star statement from a to-dos table, we would instead interact with the class to-do. And the class to-do would have an object query, which would offer us a method all, which does the exact same thing as selecting all of the records or all of the objects that belong in the class to-do. The cool thing about using a to-do.query.all statement instead of a select statement is that it gets executed no matter what database system that you connect SQL Alchemy ORM to. Recall what we said before, that every database system could potentially make you have to write SQL in a different way. When you just are using SQL Alchemy ORM, you abstract away the idea of what database system you use. So why use SQL Alchemy over writing raw SQL in the first place? Why is this something that we would want to do? Well, first off, it helps to allow us to mentally work entirely in Python instead of writing raw SQL. You would avoid making errors in SQL syntax, so you would write in these strings injected into execute statements. Writing less error-prone code leads to more rapid web development. And we can generally just forget about the database system that we're using. A very common practice is that we can switch between using a lighter database system, such as SQLite for development, and when we want to deploy to production, we can then use a heavier-handed database system like Postgres.